Hello, in this video I'm going to make a start on the 2019 Oxford PAT. So 2 hours, 24 questions, all in one block like they've had in the previous couple of years. Calculators allowed again as they were in 2018. Start off with multiple choice, which is what I'll do in this video. I'll just do the multiple choice questions and then come back to the rest later. Right, so what are we starting with? What's the next number in this sequence? Some big numbers, so let's go to the small end. Well, that's a minus a third, that's minus a third, that is all times minus a third. So we're going to end up with 4, which is D. Question 2, what values of x and y solve these log equations? Excellent. So if we're adding these up, and we can remove the logs as well then, so we can say that x times y squared is equal to 32 from the first one. And then x divided by y is equal to a half on the second one. So that's giving us that y equals 2x. So we've got 8x squared is 32. So x is equal to 2, y is equal to 4, which is A. So far so good. Right, this looks a bit more involved. Consider a system of many interacting particles. Let each particle have a potential energy VR with respect to any other particle, where VR is proportional to Rn, R is a distance, and N is an integer. Okay. For such systems, the virial theorem relates the time average total kinetic energy of all particles. Okay. To the time average total potential energy. Right, anyway, they've given us an equation, I think is all we need to know about that. If the particles in our system interact via gravity, only via gravity, what is the time average total energy of the system? Right, so the total energy is going to be the kinetic energy plus the potential energy. So what have they given us? We got the time average total kinetic energy, so that's that. And the time average total potential energy, which is that. Right, so that is going to be equal to T tot plus V tot. And they've given us a relationship between them here. So they've given us, so if it's only gravity and we're looking at potential, so, well, gravitational potential is proportional to 1 over R. So that means that N is going to be equal to minus 1. So what are they giving it? They're giving it in terms of V tot. So we need to get rid of T tot. So T tot is going to be minus a half of V tot. So that is going to be a half of V tot. V tot, is that one of our options? It's come out at C. Right, that was quite involved for a 2-mark multiple choice. It could have more that's quite involved here as well. Acceleration g due to gravity, yeah, on a spherical planet, any universe, yeah, fine. Yeah, with all the usual things. So we go to a different universe. They've doubled big G. Then they've halved the radius and doubled the density. So what has now happened on all of this? So we've got a 2 times for G at the top. The mass would have gone up by, well, they've halved the radius and doubled the density. Right, so in the radius, well, let's change it to, we're going to we'll have a radius on top because we're going to have a mass times volume, a density times volume for mass divided by a radius squared. So we're going to end up with a mass, I keep saying mass, a density times a radius at the top. So they're going to cancel out. So we're going to have 2 times 2 times a half is the total effect on this. So we're going to end up doubling it, which means we've got A. Right. So in what range of alpha does the following equation have no real solutions? Right, so we need to change it to tan squared because we can't really change the tan that easily. So sec squared is tan squared plus 1. So that means we got tan squared plus alpha tan plus 1 is equal to 0. So we need that b squared minus 4ac is greater than or equal to 0. So our b squared, that means we've got to have alpha squared minus 4. It's got to be greater than or equal to 0. So that is going to be a again. Right, probability. So we got B lots of blue balls and R lots of red balls. 2 balls are picked at random and removed from the bag. What's the probability they're different colours? So we're going to have 2 lots because it doesn't matter which way round it is. So we'd have to have a B times an R over a B plus an R and then a B plus an R minus 1 because we've removed 1. No, it's A again. We're on a run of A's. Always makes me feel edgy, doesn't it, when you get the same letter every time. Question 7. We wish to represent integer numbers by using our 10 fingers. A finger is assumed to be either up or curled, stretched out or curled up. Okay, up or down. Yeah. How many different integers can we represent with our fingers? Right, it'd be 2 to the 10. Right, so that's E. Without explicit calculation, state which integrals are non-zero. Right, let's look for things which are positive all the time, because that's not going to help. So it can't be that one. That's always positive. Oh, well, no, we're looking for non-zero. So yes, that's fine, because it's always positive. That one's always positive. These ones are either of these odd functions. It's always good to look for odd functions. So that's where you've got f of minus x equals minus f of x, because then they're going to cancel out on these. So we'd have that one would be, because it's odd. And what about this one? We will on this as well, won't we? Because, yeah, that one's going to be odd as well. So we want to have 2 and 3. So we're back on A again. Right. There we go. Lots of A's. Long, thin, straight wire carrying electric current I causes a magnetic field of flux density B. Perpendicular from the eye, if I could say it, perpendicular distance r from the wire. This magnitude is given by that equation. Okay, magnetic field points circumferentially, easy for you to say, around the wire. The second identical wire is placed parallel to the first one at a distance d. Find the current I2 that has to flow in the second wire if the flux density at a line halfway between and parallel is to double. My word. Right, so they've told us we've got some wire which has got a field around it like that with that magnitude. We've now got another one here. So we need them to add up that way. So it's going to have to be, if that was I, we're going to have I in the opposite direction. So we're going to have D. So, yeah, all good. Looks like it might have been more difficult than that. When the phase of the moon is seen from the Earth is full, what is the phase of the Earth as seen by the moon? Right, so we got a full moon from Earth. That means we're going to have Sun, Earth, and then moon just off to the other side. So that's how we can see the whole lot of the moon, in which case the moon is looking at the Earth more or less in the way of the sun. So it's going to be a new moon, or a new Earth. I should say, not a new moon, a new Earth. Question 11. In the circuit shown below, all resistors have the same resistance R. Yep. Light bulbs fixed resistance. You wish to change the state of the switches so that the brightness of the bulb increases from minimum to maximum. Which sequence do you do? All right, so we're going to have off, then A or B, then the other one, and then the one at the end. Right, okay, or maybe have something open. So we want to maximize the current, which means we want to minimize the resistance. So if we've got just A, what would happen if we had just A? We'd have a resistance of 1.5. If it was just B, then we'd have a resistance of 2. If it was both, we'd then have to add those up. So that'd be 6 over 4 plus 6 over 3, which means we've got 6 over 7 is our R. That's good. So if it's both, yeah. So we just need to go from low to, what do we want? We're going to go from minimum to maximum. Right, okay. So we want to go from, so we want to do B, then A, then both is what we want to do. So B, then A, then both is C. Good, good. Now we've got organ pipe open at one end, close at the other. Right, this looks like standing waves then. Lowest note you can play as frequency F min. So that's going to be doing that. So that's going to be a quarter of a wavelength. Speed of the sound in the pipe is V, which is frequency times wavelength. What is the L of the pipe? Right, so that's F min. So V is F min times, well, that's lambda over 4, so 4L. What am I trying to work out? I'm trying to work out L. So L is going to be V over 4F min, which is B. Right, this is groovy all round. Oh, and that's the end of the multiple choice. So as with the previous papers, they're keeping the multiple choice relatively easy. They certainly don't hide away from some very difficult questions later in the paper, but yeah, at the start, the multiple choice ones aren't really that bad. So that's done that section. Be back in a bit with the rest of the paper.